So as I was saying on 63, this should be negative infinity instead of positive infinity because you get a positive on the top, you get a negative on the bottom, which produces a negative. So that should be negative infinity. On the next one, -1, if I plug -1 into the top and bottom, it turns both of them 0. So that means I got to do some work to get rid of that because I got to get rid of a hole. So I factor the bottom, which is a sum of cubes. So that factors into x plus 1 times x squared minus x plus 1. X plus 1's cancel, gives me 1 over x squared minus x plus 1. And then I plug in -1 again. So if I plug in -1 this time, I get a 1 plus a 1 plus a 1, which gives me the 1/3. On 67, I plug in 1, which gives me a number on the top, gives me 0 on the bottom. So a number over 0 means I'm dealing with an asymptote. I think that says minus, so we'll say the left side. So the top the top is going to be negative. Well, yeah, no, the top will be positive because we're just to the left of 1, so everything's positive up there. And on the bottom, if I'm just to the left, that's going to be negative, so I get a positive over a negative, which gives me negative infinity. Next one, get a common denominator, gives me this. I plug in 0, gives me a number over 0, which is an asymptote. I plug in something to the right, so something to the right of 0 is still going to be the negative on the top, positive on the bottom, a negative and a positive gives me a negative. Plug in 0 here. Notice this is a special trig limit, so my answer is 4/5. That one should be pretty straightforward. On the next one, I plug in 0. Cosecant of 0 is undefined, so I can't put it in like that. I'm going to move cosecant to the bottom and make it signed. So I have a number over 0, which means I'm dealing with an asymptote. I plug in 0 from the right. So on the right, sign is going to be positive, and I'm going to be positive. So two positives turn me into a positive. This one is 1/2, so I plug in 1/2. I get a number over 0, so it's an asymptote. Plug in something to the right. It's going to be positive on the top, positive on the bottom, which gives me a positive. 66, I plug in -1, gives me a 0 on the top and a 0 on the bottom, so I'm going to have to do some factoring. So x to the 4th minus 1 is a difference of two squares, which factors into this, and then I can factor x squared minus 1 again, which gives me x plus 1 and x minus 1, times x squared plus 1. I should have parentheses around that. That's pretty sloppy. X plus 1's cancel, gives me 1 over x minus 1 and the x squared plus 1. Plug the -1 back in, I get a -2 there. I get a 2 there, so -2 times 2 gives me a 4, -4 on the bottom, and that's where I got the -1/4. Plug in -1, -1 on the top gives me a number, -1 on the bottom gives me 0, so number over 0, dealing with an asymptote. I'm going from the right side, so the right side of -1 is going to be positive on the top. Right side of -1 is going to be positive on the bottom, and that's how we get a positive. Plug in 2, so I get a number over 0. So it's an asymptote. We're dealing with the left side. So the left side of 2, if I square it, it's going to be smaller than 4, which means my denominator is negative. So 1 over a negative, 1 over a negative gives me my negative infinity. 0, plug in secant of 0. Secant of 0 is 1. And I plug in 0, so that's a number over 0. I went ahead and moved the secant to the bottom to make it easier to think of for me. So if I plug 0 to the right, positive, 0 to the right is positive. So that's how I get positive infinity. 74, plug in 0, cosine of 0 is 1, or cosine of 0 is 1. I square that, I still get 1. 0 on the bottom, number over 0 gives me an infinity. Since the top is squared, that means it's always going to be positive. If I'm going the left side of 0, that means the bottom's going to be negative. A positive and a negative gives me a negative. And finally, what is the requirement for the EVT and what does it guarantee? The requirement for the EVT is that the function must be continuous, and it guarantees that the function has an absolute max and an absolute min on the interval. So there are your answers to review for quiz 2.